When's the last time you actually clicked a link after Googling something? If you're honest, it's actually getting a bit rarer, right? Because now Google just tells you Perplexity does that, ChatGPT search does it, and it feels like magic, right? But there's no magic here. There's a really interesting engineering problem underneath all of this. Today we're going to tear it apart. How does AI search actually work under the hood? So let's start with what's actually different. Traditional search, where Google's original model is basically an extremely well-tuned index. You type something, it does a lookup, ranks pages using PageRank and a bunch of other signals, and gives you a list. Your job was to click around and find the answer yourself. AI search flips this completely. Instead of handing you links, it reads the web for you, synthesizes the information, and just gives you the answer. The key word here is synthesize. That's the hard part. So let's break down how that pipeline actually works. At a high level, every AI search system, whether it's Perplexity or Google AI mode, runs some version of this three-stage pipeline. First, understand what the user is actually asking. Second, retrieve the right information from the web or a knowledge base. Third, generate a coherent, grounded answer from the retrieved content. This is the RAG pattern, Retrieval-Augmented Generation. And if you have heard of it before, this is one of the most important real-world applications of it. So now let's go deeper into each stage because the devil is absolutely in the details here. So when you type a query, the system doesn't just fire it straight into a search API. It first tries to understand what you're actually asking. So there's intent classification going on. Like, are you asking a factual question? Looking for how to, comparing things. There's also entity extraction, pulling out the key concepts like JavaScript framework and temporal awareness, and system recognizes 2024 means you want recent information. So this is where a lot of intelligence lives, honestly. A bad query understanding step will tank everything downstream because you'll retrieve the wrong stuff entirely. Retrieval is honestly where most of the complexity lives. You've got two main strategies here. The first is classic web search, hitting a search API like Bing or your own crawler, getting back the URLs, scraping the content. The second is vector search, embedding the query and finding semantically similar chunks from a pre-built index. Most production systems actually use both. So you do a hybrid retrieval, key search plus semantic search, and then re-rank the results. Perplexity is heavily web search driven because it needs real-time info. Google AI mode has a massive advantage here because they have their own index and they can do things no one else can. Here's a nuance that a lot of people miss. Your initial retrieval gets you, let's say, 50 results, but you can't just dump all 50 into the LLM, right? So, because that's too much context and a lot of it is just noise. So, what do? You run a re-ranker. The retrieval step uses a bi-encoder. It's fast, good at recall, but not super precise. The re-ranker is a cross encoder, means it's a little slower, but it actually reads the query and each document together to score true relevance. You take your top 50 down to maybe 5 or 6 high quality sources, and that's what goes into the context window. The quality of this step determines whether the final answer is good or garbage. Now, here's where the LLM comes in, and this is a specific use of the LLM. It's not doing free-form generation from its training data, it's doing grounded generation, meaning it's given the retrieval documents and told answer the user's question using only this context and also cite your sources. This is actually really important because it's what separates AI search from just asking ChatGPT something. ChatGPT might hallucinate because it's relying on training weights. A properly grounded AI search system is anchored to actual web content it just retrieved, and the citations you see in Perplexity aren't decoration, they are a constraint on the model's behavior. Let's talk about Perplexity specifically because they have been pretty open about how they work. They built their own LLMs called Sonar, which are fine tuned versions of open source models optimized specifically for this search and synthesize task. On the retrieval side, they rely heavily on Bing Search API for web results, plus their own crawler now. So there's a query rewriting step, that is, your original question gets reformulated into better search queries, then retrieval, re-ranking, and generation. What makes Perplexity interesting is they are basically a thin but brilliant orchestration layer. They don't have their own index, their edge is the pipeline quality and the UX. And honestly, that's a very real engineering mode. Google AI mode is fundamentally different beast because of one thing, vertical integration. Google owns the index. They're not hitting an external search API. The retrieval layer and the generation layer are being built together. They can inject knowledge graph data, structured facts they have been building for a decade now directly into the context. They also introduced something called the query fanout. The system actually runs multiple parallel subqueries automatically, aggregates the results, and synthesizes across all of them. So instead of one search, you might be running five behind the scenes. That's a level of infrastructure most companies simply cannot replicate. One of the biggest engineering challenges in AI search is latency. Users expect search to be instant, but look at what's happening. You're chaining multiple network calls, a re-ranker, and an LLM generation all in one sequence. So that's a lot. And the tricks the industry uses is aggressive caching of common queries, speculative retrieval, that is, start fetching before query understanding is done, and streaming the answer token by token so it feels fast if total generation takes 2 seconds. And running retrieval and partial generation in parallel where possible. Perplexity uses streaming really well. You see the answer actually being built, which changes the perception of speed even if actual latency is the same. This is the question everyone asks: does AI search hallucinate? And the answer is less than a standalone LLM, but it still can. The grounding mechanism helps a lot. When the model is anchored to retrieve content, it's much less likely to make things up. But here's where it can still go wrong. If the retrieval step returns bad sources, the model might faithfully summarize in misinformation. So it's grounded, but grounded in something wrong. So this is called grounded hallucination, and it's subtle and tricky. The solution is source quality filtering, checking domain authority, publication recency, cross referencing multiple sources. This is an active research area, and none of the major players have fully solved it. So, where does all of this go? A few directions that are actively being built right now: agentic search, that is, instead of just answering a question, the system takes actions. It browses, fills forms, books things. OpenAI's operator, Google's Project Mariner, they're going here. Multimodal retrieval, that is searching across images, videos, audio, not just text. And finally, personalized search indexes, where AI search can tap into your own documents, emails, calendar combined with the web. The infrastructure challenges here are enormous, but the direction is pretty clear. Search is becoming less fine and more do. All right, let's wrap this up. AI search isn't just one thing, it's a pipeline. Query understanding, retrieval, re-ranking, grounded generation. Perplexity wins on orchestration and UX. Google wins on infrastructure and index ownership. The hard unsolved problems are latency, trust, and hallucination. And the next frontier is making search not just answer questions but actually do things. If you want to understand the AI systems that are changing how the entire web works, this is the architecture you need to understand. If this was useful, subscribe because we go this deep every week. So, see you in the next one. Thank you.